Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody, let me know if I'm clearly visible and audible to you. Everybody in the comment section, let me know if I'm clearly visible and audible to you. And wait a minute, let me just see that myself also. Okay, so is it visible, students? Very, very good evening. Very good evening. Let me just again refresh it, right? Okay. Yes. So today we are going to do coordination chemistry, right? Coordination chemistry. Good evening, DNA batch. Welcome, welcome, Jhankar, Bhargavan, Praveen, Ashmit. Okay. So, day before we did chemical bonding, and today we are going to do coordination chemistry. Okay, coordination chemistry, basically this is a very, very important chapter, both chemical bonding and coordination chemistry, right? And they are very scoring as well for JEE Mains, right? Predictable questions based on the theory they ask. In block chemistry, it's more of regarding your memory, right? What if you have very strong memory, you will be able to answer that. But in coordination chemistry, if your core conceptual knowledge is good, right, then definitely you can score full marks from chemical bonding and coordination chemistry. That is why I teach these two chapters one day after the another, right? Okay, because they are slightly related to each other. So coordination chemistry, right? How many students find it difficult? How many students find it tough? Which is your most favorite topic? Let me know in the comment section. Which is your most favorite? So I'll tell you firstly here, which is exactly what are the good topics here from where you will definitely see questions. Even in attempt 1, you must have seen that the questions that I told you directly, those questions were there in your JEE attempt 1, right? Attempt 2 is going to be slightly tough as compared to attempt 1. So we are going to prepare ourselves for attempt 2 as well according to the level of attempt 2, right? So here if you see this here, first topic, very, very important, that is Werner's theory, right? Werner's theory, directly the questions that they ask are based on what is the formula of the compound. They will give you certain hints and you have to tell according to Werner's theory what will be the formula of that compound, right? Second very important thing is isomerism. Now from isomerism, the questions are asked mostly based on geometrical and optical isomerism. Mostly you will see question based on geometrical isomerism, right? Then third one is very, very important, VBT. Here they can ask you the magnetic moment or the hybridization based on the VBT. This is a definite question that they will ask you, right? This is like, this question will definitely be there in your exam from Werner, from isomerism, and third topic is CFT. They will choose that maybe in some attempt, in some shift, they will ask question from isomerism and CFT. In some shift, they will ask question from Werner's and isomerism. In some shift, they will ask question from CFT and Werner's. But this VBT is for sure to be there in your exam, right? Okay, so these four topics we are going to do in today's lecture. Okay, in today's lecture, we are going to do these four topics. Let us start that without wasting any time. Okay, students? Yes, everybody? Ligand, counter, ion, metal, ion. It's very easy. Yes, very easy. Good. Because it is also scoring. Right? Okay. So, I want to see that energy also in the comment section. Right? The class should be energetic. And it's not going to be a very lengthy class. Right? I'll finish it at around 7:30 maximum, right? But this 1.5 in this class, no distractions, nothing. I'll teach you with the help of these very beautiful, beautiful bonds, 3D shapes wherever they are required, right? Okay, with the help of tricks also we are going to see this. Now, starting with the first thing here, first is Werner's theory, right? So what exactly is Werner's theory? Let us talk about that. Werner theory, one question that they ask you is based on this particular concept, this particular experiment, and in JEE means directly the question has been asked on the basis of color, right? So I'll tell you how to do that. Oops, wait a minute. Yes, how to do that. First is experiment that led to Werner's theory. What was that experiment? The experiment was that he had, you just need to know this particular table, okay? Just remember this particular table and you're sorted for Werner's theory. Now, this is what they will ask you in the question. Here I'm not going to teach you in a theoretical manner that this is it, and answer me. No, I'll teach you every single topic, those 4 topics I'll teach you that how they will ask you the question. From that, we are going to understand the topic. That is going to be our criteria for the next days also, next 1 month. That is how we're going to learn different chapters, okay? So the question that they ask you in the exam is not how many electrolyte 1:3. This is not asked to you. This is the hint. This is the hint that is given to you, and this is the question that is asked to you. They will give you that one simple thing is that in a coordination entity, the things that are inside the coordination sphere. This is the coordination sphere, coordination bracket you can say. The things that are inside the coordination sphere will not dissociate into ions. But the things that are outside the coordination sphere will dissociate into ions. Let us say if it has Cl2, if it has 1 Cl, then 1 Cl can be dissociated. If it has 2 Cl, 2 Cl can be dissociated. If it has 3 Cl, 3 Cl can be dissociated. So that means in this theory, we are going to talk about how many Cls are outside the bracket. And for that, what we are going to do in this particular theory, they are going to react this with AgNO3. Because chloride ion with Ag, they forms AgCl precipitates. AgCl precipitates are formed. So the AgCl precipitates are going to tell how much amount of Cl are there outside the coordination bracket. According to that, we will define the answer. Now, a very interesting question based on this, asked in 2023, we will calculate that has mixture of mole concept with the coordination compounds, right? So these mixed questions are asked in your JEE means, right? So you have to be very well aware of these things. Now, if you see this here, as you can see, 3 Cl are outside. So it is 1:3. 2 Cl are outside, 1:2. 1 Cl is outside, 1:1. 1 Cl is outside, 1:1. Now, ma'am, the question is, ma'am, here you have 3 Cl outside, the color is yellow. Ma'am, here is 2 Cl outside, color is purple. 1 Cl outside, color is green. But ma'am, another Cl, ma'am, in these 2 compounds, you have 1 Cl outside. But this is of green color, this is of violet color. Can you tell me the reason? What is the reason? Ma'am, you were telling that outside the bracket, how many Cl you have, that will tell us the color of the compound. But ma'am, here you have 1 Cl outside. 1:1, here also 1:1. Then how can you say this is green, this is violet? Ma'am, is this wrong in our book? Is it the same thing that is in the NCERT? Yes, right? This is because of the isomerism. This question also can be asked to you, right? That what is the color of this compound is also green, the color of this compound, same compound is also violet. What is the reason behind that? So many points can be there. The reason is isomerism, right? So because what it will show us geometrical isomerism that I'll teach you. Because of that isomerism, the structure, the spatial arrangement is different. That is the reason the color of these 2 compounds are coming out to be different. A very important question hidden in your NCERT table, right? Okay. Now, let us see one more aspect of Werner's theory. Not very much asked, but still you should know this particular point here. That primary valency, whenever we will talk about, this represents the oxidation number. Just remember, this represents the oxidation number. All the qualities of oxidation number, whenever you are calculating that will represent primary valency, and secondary valency is nothing but it is coordination number. It is coordination number. Ma'am, how can we remember this? Now you all know, है ना, Gen Z. Gen Z culture is that whenever something, what do you mean by OP? OP, 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 OP. Whenever you spam something, OP, right? So this is the same thing. Even you have a book of chemistry that is OP Tandon. From there also you can remember this. Primary valency is oxidation number. Okay. Usually students interchange it. That's why I'm telling you that either remember OP or remember PO. From that you can easily remember that, okay, primary valency means oxidation number, right? So whenever they ask you in the question to calculate primary valency, simple, calculate the oxidation number, because nowadays they are not asking what is the coordination number, they are asking what is the secondary valency. So that's where students get confused, right? Now let us see this question asked in 2023. Okay, this is a question of 2023. I'm not sure if you are able to see this or not. This is a question of 2023 JEE mains. Let us calculate, where they have given us that on treatment. Now, the question is given in the forms of molarity, in the form of volume, right? And they have given us AgNO3. So, these kind of question is what I want you to have mastery over, right? If you actually want to crack JEE mains attempt to, these simple questions, but also slightly mixture of two chapters, mole concept and coordination chemistry, right? So here they are saying on treatment of 100 milliliter of 0.1 molar solution of COCl3.6 water. This is the compound. So I'll just write the compound name here, that is COCl3.6 water. Now, can you see what they are asking you? Basically, they are asking you how many Cls are outside the bracket. For that, I told you that we have to know how many AgCl precipitates are formed, right? Let us see how you will calculate the AgCl precipitates here with excess. Now, they are saying on treatment of this much of COCl3 with excess of AgNO3, right? What if I am able to calculate the number of moles of this particular compound and number of moles of AgNO3, right? If I have the number of moles of AgNO3 and the number of moles of that compound, I can easily calculate that. I'll tell you how, right? I'll tell you how. Firstly, let's have this margin line over here, right? Now, if you see number of moles of this compound, I'll say number of moles of this compound, that is, we know that on treatment 100, tell me what is the formula of molarity. Molarity is equals to number of moles divided by volume in liters, right? That means number of moles can be molarity into volume in liters, right? So I can easily calculate that. Here volume is given in milliliters. So if volume is given in milliliter, it will be number of moles, volume in milliliters, then this will be multiplied by 1000, right? So number of moles will be volume multiplied in milliliters divided by 1000, right? That will be the number of moles here, right? That will be the number of moles, isn't it? That will be the number of moles. From here, I can just put the value of volume, that is volume. I'll just write the formula here, volume in milliliter multiplied by the molarity divided by 1000 here, right? From that, we can say that volume in milliliter is given to be 100. This is divided by 1000. Multiplied by molarity is nothing but 0.1. 0.1 means it is nothing but 1 divided by 10. This cancels, this will be 0.001. 0.01. Okay, this will turn out to be 1 by 100, that is 0.01. That is the number of moles of the compound that we have used here. After that, what we are going to do, let's calculate how many number of moles of AgNO3 you have. We know that number of moles of AgNO3, you can calculate this by number of moles of AgNO3 is going to be, now tell me what is given to us, excess of AgNO3, this much ions. Now there is one more formula of number of moles. Number of moles equals to, yes, very good, number of moles equals to atoms. What is the formula in ions and atoms? That is number of atoms or ions, that is 1.2 into 10 raised to power 22 divided by the Avogadro's number, that is 6.022 into 10 raised to power 23, right? So AgNO3 is 1.6 into this, it will turn out to be, if you cancel this is 10 here, that will be 24, right? So this will be 24, this will turn out to be approximately 2, so it is 2 into 10 raised to power minus 2, 22 minus 24, so will be 0.02. Now, from here we can easily say that 0.01 is the number of moles of this compound, 0.02 is the number of moles of this AgNO3, right? That means 0.01 will give you 0.02. The same number of moles of AgNO3 means the same the number of moles of AgCl you will have. Now 0.01 is giving us 0.02 AgCl precipitate. That means 1 will give you 2 AgCl precipitate. That means 2 Cl outside the bracket, right? So here you can say 2 Cl outside the bracket. We can say it is in B option. So answer is going to be B is the correct answer. Okay, understood? B is going to be the correct answer. Is that clear to everybody? So we used mole concept to answer the question of coordination chemistry, right? That is how the questions, good level questions, are asked to you. And I will not say these are difficult. These are slightly not even tricky. These are basically mixture of two concepts. If you know both the concepts, you will easily be able to answer this. So answer is going to be B is the correct answer, right? Okay. Next question here is JEE Mains 2023 question. That is, which one of the following complexes will consume more? Now this I want you guys to answer. Okay. Let us see who is going to answer this first. First question was a little lengthy, but this question very simple. Which one of the following complexes will consume more equivalents of aqueous solution of AgNO3? The one which has more Cl outside will give us more AgNO3, will consume more AgNO3, will give us more AgCl. Right? So simply let us see which has maximum AgCl. Very good. So this has 3 Cl, this has 2 Cl, this has no Cl, this has 3 Cl, this also has no Cl outside. So answer is going to be C is the correct answer. Right? C is the correct answer. Is that clear? Is that clear to everybody? Okay. Now, next question is difference between double salt and complex salt. That means coordination complex. See, if you have equimolar ratio, according to that you will have double salt or coordination compound, right? Okay. So in coordination, double salt is basically, for example, you have potash Lm. I'll just show you that. Potash Lm, right? Then you have Mohr's salt. Mohr's salt. So basically, this is formed by equimolar ratio of two salts when you use. Equimolar 1 ratio. This is also 1 ratio. When you use that, you have the double salt. And two major double salt in your syllabus that they ask you is potash Lm and Mohr's salt. Right? Fitkadi. Right? Then here you have complex. If you have non-equal, that means non-equimolar ratio. Right? One is maybe 1 ratio, other is 2. Right? 3:1, 4:1, 1:3, 2:3. In that complexes, you have the formation of coordination complexes, which has this kind of coordination sphere that we are going to study in this particular chapter. Right? Now, let us see what kind of question they have asked you in JEE Mains 2023 regarding this topic. Very simple topic. They have asked you one question here, that is, which of the following are the example of double salt? Can you tell me the example of double salt here? So as you can see, ma'am, all of them are seen to be double salt, ma'am. What can we say? I told you double salt is equimolar ratio. Equimolar ratio, right? You just have to tell me which you can see is the equimolar ratio. This is 1, this is also 1, right? This salt is 1, this salt is also 1. This is 1, but this is 4, so this is not equimolar ratio. This is 1, so this is equimolar ratio. This is 1, this is 4, this is also not equimolar ratio. So answer is A and C is the correct answer. Can you tell me what is the name? FeSO4, what is one of them is potash alum, one is potash alum and one is the moher salt. Can you tell me which of the following is potash alum and which is moher salt? Anybody in the comment section? Which is potash alum? Which is moher salt? Yes. Yes, I'll smile, Joy, once you answer the questions. Then I'll smile. Hai? Okay. So here, as you can see, this is moher salt. You should know the formulas also. This is moher salt and this is potash alum. This is potash alum. Okay, you can remember this by aluminium Al. This is not exactly, this is not alum because of aluminium. This is how you can remember this. Potash alum. This is potassium, alum, aluminium. Right? And this is moher salt. Right? Two very, very important double salts that they can directly ask you in the exam. Now, two topics we have already done, right? Okay, one very major topic, other is very small topic. Now, third concept is some definitions here, how they can ask you questions based on some basic definitions. And if you don't know these particular things, then you won't be able to understand either VBT or CFT, you won't be able to understand. Right? So let's go through this particular concept here, that is a definition of some important things. So basically, guys, you should know that here this is called sentimental atom, this is called ligand, the one that is donating, this is the one that is accepting, and here you will have some counter ion like SO4, Cl, Br, these are the counter ions, and this particular sphere is called the coordination sphere. Right? Now, coordination entity, that is over here, coordination sphere, ion and the ligands are attached to, enclosed in a bracket, right? This parenthesis is called the coordination sphere. Now, ligands are of three types: neutral, positive, negative, right? Neutral ligands, example are ethylene diamine, example are NH3, example are aqua, H2O. Positive ligands are, let's say the example are NO positive, right? Other examples, yeah, there's so many examples of positive, NO positive, mostly you will see NO positive only in your syllabus. Negative are frequently used, that is CN negative, oxalato 2 negative, right? Very important, Cl negative, Br negative, right? These are the important negative ligands that has negative charge, okay? Next is on the basis of denticity, how the ligands are distinguished. Denticity means the donor sites. If any ligand has only one donating site, that is called unidentate. Like you have Cn negative, it has just one donating site. Cl negative, Br negative, right? H2O, this is also having just one donating site. NH3, all these are having just one donating sites. Okay. Now, next is bidentate. Bidentate means which has two donating sites and both the donating sites are active at particular point, right? So here it's like oxalato, right? Oxalato means you have two carbons and they are double bond O and this is O negative, this is double bond O and O negative. You can say one donating site and this is the other donating site. So two donating sites are available here, this negative and this negative. Talking about ethylene diamine. Ethylene diamine means you have C, this is H2, this is H2 and this is combined with this NH2 here and one more NH2. Now because of the lone pairs on the nitrogen, it has two donating sites. Okay, that is ethylene diamine, frequently used. Like now, next is tridentate ligand, which has three donating sites. Like if you talk about diethylene triamine. Diethylene triamine means you have three amines here and like one carbon, another carbon that is attached to this nitrogen here, then one carbon, another carbon, again it is attached to nitrogen. So it is diethylene, two ethylene groups you have, first and second ethylene triamine, and each are attached to one amine. Right. So now here you have three donating sites, first, second, and this is the third donating site. Three nitrogen are the donating sites. Tetradentate is, if you talk about triethylene tetramine. Triethylene tetraamine means you have one ethylene, second ethylene, third ethylene, right? And these two are attached to one amine. These two are attached to one amine. And in the end also there is one amine, right? So that means total you have four amines, one donating, second donating, third donating, fourth donating sites. Four donating sites, that is tetradentate. Now very important that we have is EDTA, ethylene diamine tetraacetate, right? EDTA, you have to see whether it's hexadentate or pentadentate or tetradentate, how you will see that. Just simple thing about this is, you know what is the structure of ethylene diamine? Ethylene is this thing. Diamine means you have two NH2 group here. That is diamine. Now, when you talk about, when you remove hydrogens and you replace this by acetate group, okay, you remove two hydrogens here, you replace this by acetate group, that is CH3CO negative. This is CH3COO negative. This is CH3COO negative. This is CH3COO negative. Now, if I talk about, let's say, ma'am, if we talk about EDTA neutral, if EDTA is neutral, they have not given us any negative there. That means one donating site and this is the second donating site. So EDTA, very important thing guys, I'm writing here for your JEE mains, right? If you have EDTA simple, right, that is having two donating sites. If you have EDTA with one negative, EDTA with two negative, EDTA with three negative, right? EDTA with the four negative sign here, right? Okay. So now here what you will observe, one negative means one hydrogen is replaced by the negative charge. Here you have 1, 2, 3 donating sites, right? Now EDTA 2 negative means one more hydrogen is replaced by negative charge. Here you have 4 donating sites, tetradentate. One hydrogen is replaced by negative charge, 3 negative charge, and 1, 2, 3, 4, 5 donating sites, pentadentate, right? Now one more negative charge you have here, right? And here you have 1, 2, 3, 4, 5, 6 donating sites. That is why it is called EDTA. 4 negative is hexadentate. You need to identify that which negative is there, right? Sometimes they don't write negative, sometimes they write hexa, sometimes they write tetraacetate. If you have tetraacetate, that means 4 acetate. This is acetate group. If you have CH3COH, that is acetic acid group. This is acetate group. Okay, so that is also one more important thing, right? Okay, next is ambidentate ligand. So ambidentate ligands are which has two donating sites, but at one point only one site is available for the donation. Like you have NO2, right? And ONO. Sometimes nitrogen will donate, right? Sometimes nitrogen will donate. Sometimes oxygen will donate. They will not donate simultaneously. Sometimes nitrogen, sometimes oxygen. CN negative, right? That is also very nice. Yes. Okay. Now, next is chelating ligand. Now, I told you about bidentate ligands, okay? Bidentate ligands are responsible for chelation. So, basically what happens here, let's say you have a metal here. Let me see if you are able to see this. I don't think so. So, I'll just rewrite it, right? So, this is the metal, okay? This is the metal. Now, here you have this donation, right? NH2. Here you have this donation, NH2. This is ethylene diamine, right? This is ethylene diamine. Now, what will happen? Because it is a bidentate ligand, it will donate from this side. It will donate from this side as well. Now, because of this, there is a ring formation, that is 1, 2, 3, 4, 5. 5-membered ring, right? There is formation of ring here. Because of this ring, it provides extra stability to this structure. That is called chelating. That is called chelation. It is di or polydentate ligand which uses 2 or more donor atoms to bind a single metal, producing a ring which provides stability to that particular structure. That is called chelating effect. Last definition here is homoleptic and heteroleptic. Homo means only one ligand attached. one ligand, one type of ligand, right? Here you have more than one type of ligand, more than one type of ligand. If you have more than one type of ligand, that is called heteroleptic. Now, if you see this here, other two definitions are of coordination number and oxidation number. Definitely very, very, very important. Why I'm teaching you these definitions? Directly from definitions, very simple questions are asked. Okay, so we should not be like, ma'am, I'll do the tough question. Easy question, ma'am. Easy question will give you the same number that a tough question will give you. That why would you want to leave the easy questions, right? That will be stupidity, right? Then, ma'am, I will not do these easy questions. Ma'am, please teach us some difficult question. Easy question is also giving you the same number, right? So here it is. Coordination number of metal. They will not ask you the definitions here. Let's be clear on that. Number of donating sites. For example, let us say you have metal. You have CN6. Now tell me what is the coordination number. If you have metal, now you tell me what is the coordination number. If you are able to understand these 2 points, that means you have understood coordination number, right? Everybody, let me know. And also don't forget to like this video, like this session, share this among your friends, right? Don't be a lazy person. Don't be someone who is very jealous of everybody that I will not let them learn anything new, right? Share this among your juniors also. That will help them as well, right? Okay. Now, yes, everybody, yes. Yes. Both 6. Very good, very good, very good, very good. Okay. Now here, if you see this here, this is having at one point, one nitrogen is donating the electron here. So it is 6 donating sites. Here, En is having 2 donating sites and you have 3 En. That means total 6 donating sites you will have. Sometimes we just remember the number of ligands. No. Number of ligands, so number of ligands are 3 here. So you have to remember the number of donating sites, not the number of ligands. Number of donating sites. Okay? Yes? Yes, sweetie. Yes, sweetie. Yes, sweetie. Now please focus on the class, right? This is not the question that they're going to ask you in JEE Mains. When did Diksha ma'am got married? This is not the question that they will ask you. So focus on the board, right? Okay? We are not here to talk about, all these things which are not beneficial for you, right? We will chit chat. We will definitely chit chat once you are over with your exams, right? Now here, oxidation number. Charge on centimetal atom, right? That you have to find. Now, let us see you have CO. I'm just giving you a random example here, right? Here, this is, let's say, CN3. Let's say this is 2 positive. Randomly, I'm giving you some example, right? How you will calculate the charge. Let's say they have written here Cl2 also, right? Now, how you will calculate the oxidation number? Very simple. Take this as X. If this is a neutral ligand, this will be 0. You will say, ma'am, how will I know which is neutral, which is what? I'll give you a table for that. Okay? I'll give you one table. Go and revise that table on daily basis, right? Until and unless you are able to recall every single ligand, right? So this is 0 because it is a neutral ligand. This is negative ligand, so it is -3. Why? Because basically it will be plus -1 into 3. Because 3 ligands which are of -1 charge equals to. Now this is always cation then anion. Because here you have 2 Cl, right? That means here on the anion you will have 2 positive charge. So here you will write equals to +2. Okay, that will be overall equals to +2 charge here. That is X -3 equals to +2. So X is equals to +5. Though cobalt in +5 state is not stable, right? So this is a random example that I have picked. Cobalt in +5 state is not at all stable, right? It's just a random example just to show you that how to calculate the oxidation number, right? Now the question is, which molecule among the following cannot act as ligand in the complex compounds? Okay, this is your previous year question of 2023 JEE Mains, right? I am not picking question by myself, right? I am definitely picking the questions from previous years, right? That's why I'm saying, if you see that and this is such a simple question, then yes, this has been asked in your JEE mains, and it's not like too many years back, it's just 1 year back, right? So, which molecule among the following cannot act as ligand in the complex compound? That is, CO act as the ligand, Cn negative act as, Br act as, CH4 does not act. So, answer is going to be very good. C is the correct answer. Next question, everybody, let us see. Very good, Ananya, Jarvis, Sanjana, Physics World, Agent, Ashmita. Very good, very good, very good. Now, next question, again previous year question. This is the oxidation states of Cr in these three compounds respectively are. Now they have asked you oxidation state. Chances are in the upcoming shift they can ask you what is the primary valency in these particular three compounds, right? Primary valency is nothing but oxidation number only, right? So you can easily answer that, right? So let us answer that then. First, okay, this is the first and this is second and this is third. So let us answer that here, everybody. Let us answer that. First is CrH2O 6Cl3. Okay. Water is a neutral ligand. So this will be X plus 0. Now because on the anion, 3 anions you have. That means here you will have 3 positive charge. So it will be plus 3. X is going to be plus 3. That is chromium is going to be in plus 3 oxidation state. From here, this is all our plus 3 only. We don't even need to calculate this. Hai na? So let's calculate for B part. Let us see which is the correct answer here. That is, B is Cr C6H6. Can you tell me what is C6H6? C6H6, guys. C6H6 is nothing but it is benzene, right? So benzene has some charge. No, right? If it has all the 6 hydrogens, then it will not have any charge, right? So that means this is also neutral ligand. So this is no charge, no counter ion here. So that is X plus 0 equals to 0. So that is going to be 0, right? So here we can say that this exists in 0 oxidation state. So here this is eliminated, either option A or option D. Now let us calculate for the next part, that is K2Cr, CN2O2, then you have NH3, I don't have space now, right? Okay. Let us see how to answer that particular thing, right? Okay. Now if you see this here, if this is cation, this is the anion, right? So if here you have 2 positive, 2 potassium ions, that means here you will have 2 negative here, right? So this whole charge is going to be 2 negative here because here you have plus 2. So what we are going to answer here is, this is X, so it will be X, right? Cn is a negative ligand having -1, so it will be -2, right? Oxygen, oxygen, the superoxide, it is O2 negative, right? So it is also going to be plus, or you can just write it here, a plus of -1 into 2, plus of this is -2 into 2, right? Plus of -2 into 1 equals to -2. This oxygen has -2 charge. This O2 also has -2 charge. This you should know, right? This oxygen, it has -2 charge. That's why -2 oxygens you have multiplied by 2. One O2 molecule also has -2 charge. -2 into 1 equals to, the whole charge is -2. So it will be X -2 -4 -2 plus 2 equals to 0. And answer is going to be X is equals to plus 6. So answer will be plus 6, that is D is the correct answer. Okay, answer is going to be D is the correct answer. Got it or not? So this is turning out to be plus 6, this is 0 and this is plus 3. Is that clear to everybody? Oh, you forgot K2. Counter ions are very important, guys. Okay, you should not forget that, right? So your presence of mind should always be there, right? This is what they challenge you in the exam. They will also, why tough questions are given in the exam, just to trick your mind, that you get messed up, your mind get messed up in the tough questions, and you also forgot, you also are not feeling comfortable in answering the easy questions. So that is where they challenge, they trick your mind. So this is how, why mock test solving is so important, that when you solve the mock test, you actually train your brain for all those things that can be tricky in your, it's not like when you're solving the questions, definitely you will get improvement, but also in the exam also you will find some questions that you have no idea on. But because you have solved mock test, that is why it will be easy how you cater those questions in the exam, how your presence of mind, right, that will activate itself in the exam, right? Okay, next question is, which of the following is an example of homoleptic complex? Homoleptic complex. Everybody in the comment section, example of homoleptic. Homoleptic is very, very easy. Homoleptic means you need to have only one type of compound, one type of ligand that is there in which. Here you have only one type, that is NH3. So answer is going to be A is the correct answer for homoleptic compounds, right? Now, this table that I was telling you, that this is the table, right? That the name of anionic ligands, right? It will always end with ido or O, right? Like fluorido, chlorido, bromido, iodido, sulfato, hydroxo, cyanido, oxalato, carbonato, acetato, oxo, peroxo, superoxo, right? Okay. And this is the thing that I asked you. O also has 2 negative, O2 also has 2 negative. But if you have O2 negative here, right, that is superoxo, right? Okay. Now, this is the positive ligands. Very rarely, mostly you will see NO positive in your exam, right? So these are the 4 positive ligands and these are the neutral ligands. Out of this, NH3, aqua, CO, carbonyl is very important. Nitrosyl is also very important. From here, all the halogens, then this one, this one, this one, oxalato, carbonato, acetato, all of them are important only, right? Okay. This is how you should know the charges, right? And these are the basically the formulas and the complexes, the name as ligands that they can have. NH3 amine, H2O aqua, right? Then CO carbonyl, right? Others are simple only. Bromine, chlorine, and there is cyanido, fluorido. This is also asked. From here, you should definitely go through all of them, but I'm just telling you which are important. Oxalato is important. Oxo is very important. Ethylene diamine is very important for you, right? So these are frequently asked, right? Okay. So I will provide you with the PDF, right? Go through this particular table. Go through this particular table. Go through this particular table. These 3 tables should be on your tips if you actually want to score good in coordination compounds, right? Okay. Understood? Is that clear? Now we are just left with very few things, right? Ma'am, we have to get the session PDF. Session PDF will be provided in the description box and also in the comment section you will get the link, right, of the session PDF that will be updated for tomorrow. Right? Reason being, because your ma'am is teaching doesn't mean all the employees are there in the team, right? Everybody is on holiday. Today is Sunday. Yes, ma'am is teaching because of you guys, because I didn't want it. I know that Sunday is a free day for all of you. So I was like, okay, let's not cancel the class. Let's postpone the class, right? Okay. So now here we have isomerism. Isomerism also I'll give you 2 tables, 3, 4 tables I'll give you. You have to go through those tables. First, I'll make you understand what exactly we are talking about. First is structural, other is stereoisomerism. So structural isomerism are of 4 types. One is ionization. Ionization means when you have counter ion is different. Let's say, suppose you have one any other thing. Let's say I'm just giving you random example. This is NH3, this is SO4 and this is Br2. Okay, and here you have CO, this is NH3, this is Br2 and or you can also, yes, you can write Br2 and this is SO4, right? So in this case, what you can see that the counter ion is actually getting exchanged with each other. That is called ionization. That means the number of ions, or not the number of ions, the ions that we are getting after dissociation are different. That is ionization isomerism. Next is linkage isomerism. That is shown by only ambidentate ligand. If you have, let's say, NO2, if it is donating through nitrogen, that is a different compound. If it is donating through oxygen, that is a different compound. So this is linkage isomerism, how it is linked to the metal ion, right? Third is coordination isomerism. In coordination isomerism, you have two different coordination sphere, one coordination sphere, other coordination sphere. Let's say here you have, let's take the example of cobalt. This is chromium, right? Okay, this is chromium and this is cobalt, right? So what will happen here, right? The ligands will interchange. Let's say here you have NH3, right? And here you have water, and here you have, okay, let's keep NH3 only here, right? This is water, right? This is water, this is water. This is 6, 6, 6 and 6. Now basically these two are called the coordination isomerism because ligands are interexchanging with each other, keeping the oxidation number of the centimetal ion as the same, right? So ligand are getting interchanged in two coordination brackets in the coordination compound. That is coordination isomerism. That is how you will predict that. Last for structure isomerism is solvate isomerism. That means the number of aqua ligands, that are water molecules that are acting as ligand, is different. So let's take example. Let's say you have here 6 and this is Cl2, and let's say here you have CO, this is H2O. Let's say you have 5 and 1 Cl here, and 1 water is outside, 1 Cl is outside. Now here you have 6 water molecule acting as ligand. Here you have 5 water molecule acting as ligand. So that is going to be a solvate isomerism. Okay, so answer is going to be this and this are solvate isomers. Okay, next is if you talk about stereoisomerism, that is the structural difference, right, in 3D, how they are different with each other. So here we have two kind of isomerism. One is geometrical, other is optical isomerism. Ouch. Okay, just give me a minute. Okay, so if you talk about geometrical isomerism means, let's take an example that if you talk about cis and trans. Okay, cis means which are next to each other, trans means opposite to each other. Just remember this thing. And in geometrical isomerism, we have facial and meridional also in one case, right? So if you talk about this particular isomerism, here ligands are next to each other. Same kind of ligands are next to each other, that is cis. And if same kind of ligands are opposite, these are opposite, that is called trans isomerism, right? So that exists in square planar and octahedral, but it does not exist in tetrahedral geometry. It is a very, very important point that because of the symmetry changes, that is why geometrical isomerism is not possible in tetrahedral species, right? Now, if you talk about the geometrical isomerism, let's say this is coordination number 6 only. Now, I told you that others are very simple. If they are next to each other, that is cis. If they are opposite to each other, that is trans, right? But in case of A3, B3, this question has been frequently asked in your JEE means, right? Frequently, even in JEE Advanced, they ask this question regarding facial and meridional isomer, right? Very, very important. Facial isomer, if you also want to know that in 3D, then let me know in the comment section. If you also want to know facial isomerism in 3D, then let me know in the comment section that, ma'am, yes, teach us isomerism, facial isomerism in 3D. Then I'll also teach you facial isomerism in 3D and what is exactly meridional isomer. Right, in 2D also I'll teach you what exactly, how you will find the facial and meridional isomer. Okay, if you want that in 3D, then also let me know. Very good best attempt only because of your revision lecture. This is the first live class I'm attending your session. Thank you so much for everything. Thank you so much, Gauri. Thank you so much, beta. I'm so happy that you got 98 percentile, right? Very, very happy for you. That actually made my day today, right? You actually made me smile today. So when you see all these things, right, in the chat box, that actually that acts as a motivational factor, right? That okay, kids are actually loving it and they are also enjoying the classes, right? And when these students, they come in live and tell about their experience, that actually makes my day. So thank you so much, Gauri, for sharing your experience here. Okay. So now, if you talk about ME3B3, two kind, always ME3B3, just remember facial meridional, facial meridional. Okay. Ma'am, firstly, in 2D, how you will tell us what is facial, what is meridional. So this is M1, 2, 3, 4, 5, 6. This is M1, 2, 3, 4, 5, 6. So if you talk about, let's say A3, facial means on one face. So this is 1, this is 2, they will be next to each other, right? In 2D, you will write it like this, B, B, and next to each other. Meridional is A, and this is A, right? Just skip one line here and make A here. Then rest of them are B, B, B. This is how you will write facial and meridional in 2D, right? But ma'am, what about in 3D? Let's take A as green. So A will be on one face, right? Same atoms on one face. Phase means this is the phase. I'll tell you, this is the phase. Why octahedral is called octahedral? Because it has 8 phases. Okay, so I'll just show you that. This is the first phase, this is second phase, this is third phase, this is fourth phase. This is fifth, sixth, seventh, eighth. That is why octahedral is called octa. Octa means 8 phases it has. Now, facial isomerism means when you have same kind of atom on one face, right? If you draw the others as, let's say, red, then red also should be on the same phases, okay? Red also should be on, wait a minute, on the same phases, right? Okay. Okay. What to do, agent? Students are changing, na? That's why I have to teach that. Or do you want us to change the syllabus? Every year, new syllabus for teachers. Hai na? Every year, syllabus is changing. So, this is the first phase. See, on the same phase, this is one phase, triangular phase, where you have same atoms. This is another phase where you have same atoms. That is called facial isomerism. When you have meridional means on one sphere. Okay, this is the hemisphere, right? When on a hemisphere, let's say, let me just teach you that because it's actually a very interesting concept. That's why I don't want you to cram this. It's actually very interesting. Okay. In this semisphere, can you see? In this semisphere, you have same atoms 1, 2, 3. This is also one hemisphere or semisphere. You have the same atom 1, 2, 3. That is called meridional because that is on the meridian plane. You have the same atoms. Okay, that is facial and meridional. Is that clear to everybody? Is that clear? Is that clear? What is facial? When on the same phase you have same atoms. When on a hemisphere you have same atoms, that is meridional isomerism. That is also called meridional plane. Right? Okay. Now, I'll tell you directly here. Right? Okay. Which of the following will show? This is a very important cheat sheet for you. This is the thing that you should remember for exam, right? For understanding purpose, I have told you, cis is this, trans is this, but for the exam, what you have to understand is this thing, right? Okay? Yes. Okay. What wrongly? What wrongly, guys? A. Wait a minute, let me see that. This is meridional, right? So 1, 2 on the same phase. Let's say we have 2 atoms on the same phase, right? On the same phase, you have 2 atoms. So it should be here. And this should be 1, 2, 3. Yes. Okay. My mistake. I'll just correct that for you. Wait a minute. Okay. Let me just see the 2 from 3D structure. I draw the 2D structure. So basically 1, 2, 3 on the same, that is if you talk about this is A, right? Then third also you have A. So A should be here, that was right only, na? A should be here, right? If you talk about B, this is B, this is B, and this is B. That was right only. Here also, if you talk about A and B, 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 let's see that. A and B, 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 let's see that also. Right, on the same phase we have to make, on the same phase means this should be, green should be here, that is on the same phase. In this much detail, no one will teach you. I'm telling you, right? So this is on the same phase, right? So that is on this square you have A, right? This is also A and this is also A. B you have here, right? B is here, here and here. Right only. Very bad, huh? Very bad. Now, okay, from here you can also see that how cramming will not help you, but understanding concepts will definitely help you, right? No matter how many times students tell me, ma'am, this is that, this is that, when you know the actual concept, no one can confuse you, right? Okay, so now here, if you see, this is the cheat sheet that you have for your JEE mains. Now for coordination number 4, I'll also tell you, if you have MA2B2, let's say MA2B2 is M. Okay, this is M here. This is 1, 2, 3, 4. A2, this is basically trans, right? And if this is M, 1, 2, 3, 4, this is A, B, B. This is cis. So that means this A2, B2 is definitely showing us, it is definitely showing us cis and trans isomerism. That is why we have written it here. If you have MABCD, can you tell me how to answer MABCD? Anybody? Very, very important concept of MABCD. Anybody? 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 Okay, let's see that. MABCD. Okay. So, MABCD is basically, if you have 4 different ligands here, how you will see. Right? So, this is M, 1, 2, 3, 4. A, B, C, D. Okay, so here what exactly we do, this is the trick to do this. Every single teacher will tell you the same trick, okay, because the scientist told the same trick. Okay, so this is fix one ligand here and rotate the other 2 ligands, other 3 ligands. So this M is constant here, right? A is constant. I am rotating the other ligands. I am switching B and C here. So that is, this is C, this is B. This D will remain same here, right? Then I am again rotating it. Now I am rotating B and D, right? So here what will happen? A will remain fixed, right? C is also fixed here because I am rotating, I am switching these 2 positions, that is B and D. So how you will write it? This was B, B will be here, this is D, right? Now, this question has been asked so many times. Why it has 3 isomers, right? Okay. So these are the 3 isomers. That is the first question that they ask you. MABCD will have how many isomers? Second question, what they will ask you is that which of the following will be cis, which will be trans. Okay. For that, what you should do, this is the way of answering that you have 3 isomers. For cis and trans, imagine that you should say that you should assume that 2 ligands are same here. I am assuming. What do you want to assume? If I see the first chat box, first chat that I'll see, I'll take that as the same. First chat that I'll see. You can say AB, you can say BC, you can say CD, you can say DB, you can say AC, whatever, right? What's your choice? The first student who will write it in the chat box, I'll take that as the fixed 2 fixed ligands. I'm still waiting for your chats. Everybody. Very good, Praveen. Very good. 2 cis and 1 trans. But let us see how. Okay, let us see how. Yes, everybody. Still not there. I'm not even asking you any question. I'm just asking you to give me one question. Okay. So Hari is saying, ma'am, take AB as the constant. So I have fixed A here, I have fixed B here, right? Now according to AB, I'll answer. I have fixed A here, I have fixed B here. I have fixed A here, I have fixed B here. Okay, now here, if I see A and B are next to each other, so this is cis. A and B are opposite to each other, so this is trans. A and B are next to each other, so this is cis. Similarly, you take any two fixed ligands, you will always have two cis plus one trans. Always and always you will have two cis and one trans for MABCD kind of complex. This is a very, very, very frequently asked question for your JEE mains, right? Okay, understood? Two cis, one trans, always and always, doesn't matter whatever you take. If it is MABCD kind of complex, right? Now, from the same, they have asked you one question, previous year question of JEE mains, that is the number of geometrical isomers that can exist for square planar. For square planar, as you can see, this is PT, A, B, C, D. So this is MABCD kind of complex. They are saying geometrical isomer. You have three geometrical isomers here. So answer is going to be B is the correct answer. That is having two cis plus one trans. Okay, two cis plus one trans. So that is B is the correct answer. Next question here is the correct statement. Acha, this we have not done. Octahedral we have not done till yet. Okay, I was just teaching you square planar. This we have done. The question also we have done based on this. Now we will talk about octahedral here, right? Octahedral, three things we have: Ma2B4. Okay, if you have Ma2B4 kind of complex, let us see if you have Ma2B4 kind of complex. That is, this is M, this is 1, 2, 3, 4, 5, 6. A2B4. So A2B4 can be A2B4. Can you tell me this is cis or trans? Or it can also be trans can be when 2B are opposite, 2B are opposite, 2A are opposite. Okay, that can be your trans. So this is cis, this is trans isomer, right? Another example here is, Everybody, the second example here is, this also we have done. Okay, here it is Ma3B3. A3B3. This is M 1, 2, 3, 4, 5, 6. This is M 1, 2, 3, 4, 5, 6. Okay. A3B3 means A3. Let us see if they are side by side. B3. Okay. If you have Ma3B3 in the trans manner, A are opposite, B are opposite, and sometimes A and B are opposite. So because maximum you have B and B are opposite, A and A are opposite, so we can say that this is a trans isomer. Okay, and this is a cis isomer. Okay, this is a trans isomer, that is a cis isomer. So that means again you have two geometrical isomer for this one. Then you have very, very important. Now this they ask you, like first is this one they ask you in the exam, then this one, right? These are the two kind of compounds that they ask frequently in your exams. That is MLL of 2 and B2. Ma'am, what do you mean by ma'am LL of 2? Can you tell me what is LL of 2? What do you mean by that? Anybody? Okay. So this is M. LL means you have a bidentate ligand, right? This is B2. So this is M, right? 1, 2, 3, 4, 5, 6. Okay, let's draw it neatly. 1, 2, 3, 4, 5, 6. This is also M. 1, 2, 3, 4, 5, 6. Okay. Here you have two kind of LL ligands. Okay, when they are placed next to each other, right? This is B and this is B, right? Two kind of LL ligands when they are placed opposite to each other. This is B and this is B. Now here, this is cis and this is trans. So we can say definitely they are showing geometrical isomers. Okay. So here you have the last one also we have answered. But in the end, you just need to remember that MEBCD shows 3 ligands. Okay. That you should know. They can also ask you which of the following will not show any geometrical ligand. So that also you should know. Okay. Now, in the comment section, tell me which of the following is correct. The correct statement, everybody, yes. For MA3B3 also it is 2. That is facial and meridional. Okay, that we have learned. Right? The correct statement, the isomerism associated with the following complex sign is the isomerism. A and B show only geometrical. This is A5B. This will not show any geometrical isomerism, right? Okay. This is MA4B2. This will definitely show geometrical isomerism. This is MA3B3. This will also show geometrical isomerism. We have seen that, right? This will show facial and meridional, right? This will show cis and trans, right? So answer will be B and C is going to show you geometrical isomerism. So D is the correct answer. Okay, D is the correct answer. Is that clear? How D is the correct answer? Is that clear to everybody here? Right? Okay. Geometrical, optical, no. Right? D will be the correct answer. Okay? Right? Okay. Then next is consider the following reaction. This reaction is given to you. It's a very, very interesting question. The isomers are produced if the reactant complex is cis isomer. Now let me just show you the reactions here. I don't know if you will be able to answer this directly or not. Just go through the question first. They have given you one reaction. Okay, this is MA4B2 kind of complex. That means cis can be there, trans can be there, right? They are saying 2 isomers are produced if the reactant is cis, 2 isomers are produced if the reactant is trans, 1 isomer if reactant is trans, 1 isomer if reactant is cis. So let's take the example of both cis and trans here. If you have cis isomer, this is how the reaction will take place, right? This is a cis isomer, right? NH3, 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 NH3 are next to each other, Br, Br are next to each other. When we add one more Br here, right? So what will happen? It will replace, basically when you're adding one more, wait a minute, here it should be NH3Br2, right? Okay, you're adding one Br here. So you're adding one Br, this is one Br, Br2, you're adding one more Br here. So what will happen, right? This NH3 will be replaced by the Br. As you can see, this is a facial isomer where you have next to each other, where the Br are next to each other, where the same kind of ligands are next to each other. So that is the facial isomerism. Also, it can replace this particular NH3 where you will have meridional isomerism. So when you have cis isomer, the answer is facial and meridional. So from cis, you have 2 other isomers that can be formed after the reaction. But in trans isomer, this is a very, very new question for all the students, right, who have done just basics, right? So for trans, when you add one Br, there is only one possibility, that this NH3, right? Even if this NH3 goes, that is the same thing. Even if this NH3 goes, that is the same thing. Even if this NH3 goes, that is the same thing, right? Because all the NH3 are on the same position, right? So it doesn't matter. It will not give rise to any new isomer, right? So if this NH3 or this NH3 or this NH3 or this NH3, any NH3 leaves and they get replaced by Br, you will have the presence of meridional isomer. If you, let's say, ma'am, here you have NH3 only, here you have Br, that is also meridional. 2 are next to each other. After leaving one side, you have one Br, right? That is the answer for meridional, right? So always for trans you will have only meridional, that is for trans you will have only one isomerism here. So answer is going to be, that is cis will have, trans will give you only one, trans will give you only one isomer, cis will give you two, cis will give you two isomer, that is first and third, that is C is the correct answer. Okay, C is the correct answer. Is that clear to everybody here? Is that clear? Is that clear in your head that how cis and trans are going to be the correct answer? Is that clear in everybody's head? Now let's talk about optical isomer, right? Let's talk about optical isomer. Till then, till here, if there is any confusion, then let me know in the comment section if there is any confusion till here. Ma'am, 1 and A. Ha. Ma'am, answer is 1 and third. Yes, that is the correct answer, definitely. Okay. Next is optical isomerism. Okay. So in optical isomerism, you will have basically they should be non-superimposable mirror images of each other. Let's say you have one isomer, right? This we can say there is one figure. Now you take the mirror image, you try to superimpose. If they are non-superimposable, that is enantiomer. That means they are optically active. Okay, that you have to see. So now here, optically active, you should know one thing. One is dextro, that rotates plane polarized right on the right side. Lever is which rotates plane polarized light on the left side. Okay, understood? L and lever means left. Okay, now let us take the example here. Let us take one example. This example we have seen here as well. Okay, so I don't need to draw it again. The same example. That means these are non-superimposable when you paste it. Here you take the mirror image, you paste it here. That is the non-superimposable mirror image. That means always and always you should know they show optical isomer. Okay, this will show optical isomerism, right? Okay. Next is you have PTCl2En2, right? Here again you should draw this firstly. First thing is you should have PT 1, 2, 3, 4, 5, 6. If you have a cis isomer, that is ClCl, and this is En, this is En, this is also En. En I am drawing just the same way. Now for cis isomer, it will not show any optical isomerism. Can you tell me why? For cis isomer, it will not show any optical isomerism. Reason being, if you make the mirror image here, that is superimposable. Cis isomer shows superimposable mirror image, so there is no optical isomerism. But for trans, you will have, for trans, what you will have, this is, let's say, En, this is En, this is Cl, this is Cl. You take the mirror image, this is PT, 1, 2, 3, 4, 5, 6. This is En, this is Cl, this is Cl, this is En. Now you try to superimpose, it will not be able to, you will not be able to superimpose this. So that means this will show optical isomerism. Optical isomerism it will show. Understood? So in total, how many stereoisomers you will have? 1, 2, 3. One is cis, one is trans, and one is the optical isomerism of this trans. That is total stereoisomer is going to be 3. Got it? Total stereoisomerism is going to be 3. Oi, hoy, I forgot. My mistake. My mistake. This is cis. Yes, this is trans. My mistake, guys. My mistake. My mistake. Yes, this is trans only. By mistake, I told this is this. Right? Huh. So this is trans only. Trans will not show any it will actually form superimposable mirror image. But cis, it will not form superimposable mirror image. Basically, it will be non-superimposable. Once you try to superimpose this here, you won't be able to do that. That's why you will have one trans and one cis. One is the non-superimposable mirror image of cis. Right? Okay? Yes. Now, from here, one more thing that you should know is Coordination number 4, right? Coordination number 4, tetrahedral will not show you geometrical isomerism, and square planar will not show you optical isomerism. This is also a very, very important point, right? Okay, because in square planar, always you will have superimposable mirror image, right? Okay. Now, this is the chart that I was telling you, you should know. Go through this chart once, right? From here, just go through this once and see, like, till here you have zero optical. This enantiomer means optical isomerism only, right? All these things, because they can ask you, in the exam, they will ask you directly how many geometrical, how many optical isomerism. So, this is the first table, second table, and third table, right? These three tables are very, very important for you, right? If you want to do things in a quick manner, if you want to save time in the JEE means, save the time and utilize that time in mathematics or physics, then these kind of tables are important for you. Otherwise, so you can draw and understand which is forming superimposable, which is non-superimposable. But go through this once, because mostly you will see 0, somewhere you will see 1, somewhere only. These, so you should not even try to like understand. I would say just directly learn that this is 6, this is 2, this is 1, right? Okay, so this is how we are going to do geometrical and optical isomerism. Is that clear? Last two topics, right? Okay, what is superimpossible? Go and firstly study 11th class. Superimposable. Imposable means which are going to, like you have these hands, okay? These hands are the mirror images of each other. If I try to superimpose, if I try to place it on one another, I can see they are not hiding each other completely. That is non-superimposable. Okay, it's not impossible, Sarathi. Okay, now last two topics, we have two theories, VBT and CFT. Okay, let us talk about that, VBT and CFT. Okay, yes, everybody, if you're ready for VBT and CFT, then green hearts in the comment section for Diksha ma'am. Yes. Yes. Okay, let us see. Now, here you have valence bond theory. Valence bond theory is basically, it is going to tell you that how metal and ligands interact with each other. So let's go through that. And with this, actually, vacant metal hybrid orbital you have ligand donated, and hence you have the formation of a coordinate covalent bond. Right? Now, what you have to remember, this so they will never give you. They will give you either coordination number 4 or coordination number 6. If you have coordination number 4, just remember either it can be sp3, which is tetrahedral, or it can be dsp2, which is square planar. Only two possibilities we have. Coordination number 4, either it can be square planar or it can be tetrahedral. If it is sp3, it will be tetrahedral. If it is dsp2, it will be square planar. Coordination number 6, two possibilities. Either it can be sp3d2, which is outer octahedral, or it can be d2sp3, which is inner octahedral. Okay, which is inner octahedral. Understood? Outer or inner octahedral, two possibilities you have here. Now, one by one we will see exactly octahedral, this is outer, right? This is inner octahedral. Okay, we'll try to understand this with the help of questions, how you will solve it, right? Coordination number 4, this is basically tetrahedral. Okay, and this dsp2 is nothing but it is square planar. Okay, square planar. Understood? Yes, this is how tetrahedral looks like. This is how tetrahedral simply means that you have these 4 bonds here, right? Okay, let's say if I draw it, this is octahedral, right? 4 bonds in one square, one up, one down. So that is octahedral. Tetrahedral simply means you have it in this kind of situation, right? Okay. Let me just show you that. Because knowing things in 3D will be way, way better than knowing things in 2D, right? You don't have to cram anything there. right? Okay, so that is VBT, right? This is tetrahedral, right? In 3D it looks like this. This is tetrahedral. Okay, this is how tetrahedral looks like. Now, after this, let us see square planar. Square planar means this thing. Square planar means, let us just eliminate these two things from octahedral. This is basically square planar. In one plane, you have one square, that is square planar. Okay, now you have an idea about these geometries. 3 geometries only you will have, right? Now let us try to answer the questions, because from questions only I will able to tell you that what exactly, how you are going to solve the questions of VBT. Theory will not help you here. You need to practice the questions here, right? So the first thing is the correct combination. You have given you two things. One is NiCN4, other is NiCl4, third is NiCO4. Okay, so three things you have here. From this question only you will be able to understand everything, right? You will first is NiCl4, 2 negative, other is NiCN4, 2 negative, third is NiCO4. I think these are the three compounds that you have here, right? Let us try to understand everything here. Same concept we will apply. Whenever we are solving the questions of VBT, this will be there in your exam for sure. A question on VBT hybridization or magnetic moment for sure, guarantee, right? Okay, so this is X minus, try to find the coordination oxidation state. X minus 4 is equals to minus 2, X equals to plus 2. If I would have directly, ma'am, this is so important, then why don't you teach this directly? Because if you don't know how to calculate the electronic configuration oxidation number, you won't be able to answer this, right? So this is plus 2 oxidation. Here it is X minus 4 equals to minus 2, X is equals to plus 2. Here it is Carbonyl. I told you, if you don't have any idea about whether carbonyl is neutral or not, you won't be able to answer this. Now, I want you to answer this. Carbonyl is neutral. It is minus 1. You can tell me the answer. Is it minus 1 or neutral? I want to see that in the chat section. Okay. Once you calculate the oxidation number here, after that, find the electronic configuration. Nickel is 28 atomic number. Saktiv Karman Fikunicogen. Right? 28 atomic number means argon 18, 4s, 3d. 28 means 28. You take out 2 electrons from here. That means 2 electrons from 4s you have taken out. Okay, so it will be this. Now here this is nothing but 3d8. Here also this will be nickel is nothing but, nickel 2 positive is nothing but it is 3d8. Here you tell me, I think by now though, yes, very good. That is neutral. Okay, so this is going to be X plus 0 equals to 0. So X is going to be 0. So here nickel is in 0 oxidation state. So it is going to be nothing but it is going to be 4s2 and 3d8. Now, once you know the oxidation number, you have found the electronic configuration. See which is the strong field, which is weak field. This is a weak field ligand. This is a strong field ligand, right? And carbonyl, you have to tell me in the comment section whether it is a strong field or it is a weak field. I want to see that in the comment section, whether it's a strong field or a weak field, right? Weak field will never cause pairing. So it will be 3d8 means this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. S, this is P3, right? Here it will not cause any pairing. So this is going to be, pairing is going to be, it will not cause any pairing. 1, 2, 3, 4, 5, 6, 7, 8. That means the electrons that you are, the orbitals that you are left with is sp3d2. So answer is sp3d2, right? sp3d2, that it is outer octahedral complex, right? Here it is strong field ligand, that means it will cause pairing, right? So let us see that. Pairing means 1, 2, 3, 4, 5, 6, 7, 8. Now here, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. D2sp3 is not possible again, right? D2sp3 is not possible again. DsP3D you can't say, right? So again it will be sp3d2 only, is it? Again it is going to be sp3d2 only. sp3d2. Why? Because you have one empty. You need to have two empty, okay? So that's why even if it is a strong field ligand, we have no benefit of that. Okay, here it is strong field ligand. Very good. This is D, this is S, this is P, and this is another D. Okay. Strong field means it will cause pairing. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 8 plus 2 is nothing but 10 electrons. Okay. So 10 electrons will be paired up, and here you will again have, I think there is some confusion that we have done, is it? 2 electrons here. It will be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Again, it will be sp3d2. Okay. If I have this thing, then it should be sp3d2 only. 10 electrons. Let us see. Wait a minute. Let us see the paramagnetic and tetrahedral. Acha, beta. Beta, why didn't you told me? Very, very big mistake we have done. What was that? You're also saying yes, yes. What was that? Beta, coordination number was 4. Coordination number was 4 here. It was not 6. So coordination number 4 means we can have either sp3 or dsp2. Coordination number is 4, right? So D2 octahedral is not possible. So here it will be sp3, okay? Here it will be dsp2, okay? And here it will be sp3. Now here, because if the coordination number is 4, if the coordination number is 6, then we have to think about D2, sp3, sp3, D2, right? So here it is 2 unpaired electron, that means it is paramagnetic, right? No unpaired electron, it is dimagnetic. Here it is no unpaired electron means it is dimagnetic, right? Can you see that? So here magnetic moment is going to be 2.7. Here it is 0. Here also it is 0. 2.7 means magnetic moment is basically under root n plus 2, right? But whenever you have one unpaired electron, it is 1.7. When it is 2 unpaired electron, it is 2.7. 3 unpaired electron, 3.8. 4 unpaired electron, 4.9. 5 unpaired electron, 5.9. So basically, this is how you're going to answer that, right? Now here it is, NiCN4 is, NiCN4 2 negative is di and square planar. So NiCN4 is di and square planar. NiCl4 is para and tetrahedral. Para, and it is NiCl4 is para. Okay. NiCO is tetrahedral. NiCO is nothing but tetrahedral. So answer will be B is the correct answer. Okay. Understood? Understood? Okay. Next is, okay, that's a very, very good idea, Deep. So I'll take one lecture on all the exceptions of inorganic chemistry. Be it block chemistry, be it theories, I'll take all the exceptions in that particular video. Okay, that will be specially designed for exceptions only. Got it? Now, next is okay. Next bit, this so we have done that ligands strong are NH3, EN, CN, CO. These are strong. Weak are I, Br, halogens, and water. These are weak field ligands, right? Okay. Next is di-para. This we have already done, right? Limitations were It involves number of assumptions. It does not give quantitative interpretation of magnetic data. You will say, ma'am, it is giving us magnetic data. Actually, in reality, it was not giving us magnetic data. We had to tell the magnetic data. Then we were finding whether pairing is happening or not. That was in reality of VBT. Scientists knew that this is paramagnetic. After that, they were checking how many unpaired electron whether pairing it is causing or not, right, from the magnetic data, right? So that is why magnetic data was not proper. Color explanation, no. Thermodynamic and kinetic stability, it is not able to tell us. Then it does not make exact predictions regarding tetrahedral and square planar. So this is important. Why? One student is saying that, ma'am, please tell the exceptions. Exceptions are because of this thing only, that there are, why exceptions are there? Because this theory was not able to, teach those particular points. This theory was not able to explain those points. So that is why that became the exception. It does not distinguish between weak and strong field ligand. Weak and strong field ligand we know from CFT, not from VBT. That's why this is also one of the limitations, right? Next is the magnetic order, magnetic spin order. The correct order of spin only magnetic moment among the following. Spin only magnetic moment, anybody? Spin only magnetic moment, how you can tell? Spin only magnetic moment, if you say this is number of unpaired electrons you have to tell. Let us talk about Zn. If Zn we talk about, this will be in Zn. Okay, Zn, this is x minus 4 is equals to minus 2. Z is in plus 2 oxidation state. Right? Everything is in plus 2 oxidation state. Nickel in plus 2 oxidation state. Right? Cobalt in plus 2 oxidation state. Manganese in plus 2 oxidation state. And there is no pairing because Cl is attached here, a weak field ligand is attached here. 30 means it had 4s2 3d10. Nickel had 28, that means 4s2 3d8. Right? Cobalt has 27, means 4s2 3d7. Right? Then manganese has 4s2 3d5. Out of this, take 2 electrons from everywhere, right? And then this is the electronic configuration that you will have, right? So here, unpaired electron, magnetic moment will be minimum for zinc because it has all the paired electrons. So minimum is for zinc, that is in this case, or this is eliminated. If you talk about this here, it is 1, 2, 3, 4, 5, 6, 7, 8. So 2 unpaired electrons. This is 1, 2, 3, 4, 5, 6, 7, 8, 6, 7. So it is 3 unpaired electron. It is 1, 2, 3, 4, 5. It is 5 unpaired electron. This is 2, this is 3, this is 5. Okay? 2, 3 and 5 unpaired electrons. So you can see 5 is having maximum, right? Then you have 3, then you have 1. So answer is D is the correct answer. Okay? Understood? D is going to be the correct answer. Is that clear? Yes. D is the correct answer here. Next is the pair having same magnetic moment. Same magnetic moment. Same magnetic moment means, okay, let's find that both Cl and water are weak field ligands. So this is chromium. Chromium is in plus 2 oxidation state because water is a neutral ligand. Here this is x minus 4 is equals to minus 2. Again cobalt is plus 2 oxidation state. Right. Here chromium is in plus 2. This is iron is in plus 2. Right. Here this is manganese in plus 2 oxidation state. Right. This is chromium in plus 2. This is cobalt in plus 2. This is iron. Okay. Let's find out for these 4. Chromium is 24. So it is 4s1 3d5. Okay. Cobalt is 27. 4s2 3d7. Iron is 26. 4s2 3d6. Manganese is 25. So 4s2 3d5. Take out 2 electrons here. 2 electrons here. It will be 4. Okay. So it will be 4 here. Right? 2 electrons from here. 2 electrons from here. 2 electrons from here. There is no pairing. So it will be 4 unpaired electron. It will be 1, 2, 3, 4, 5, 6, 7. So it will be 3 unpaired electron. This will be 4 unpaired electron. This will be 5 unpaired electron. So same are for iron and chromium. Iron and chromium, that is there in chromium and iron, that is there in B. So it is iron and chromium plus 2 oxidation state shows the same magnetic moment. That means the same number of unpaired electrons. So answer is B is the correct answer. Clear? That is how we are going to solve the question for VBT. Now, next we have, let us see how many likes. I think it must have crossed 150 plus. Is it? Yes, 113. Let's cross it 150 plus, okay, before the end of this class. I see you don't comment down, है ना? You don't comment down. You know that I see your comments, right? My favorite thing to do is go through my lectures and see what are the comments that I can see in the videos, right? Okay, that is the best thing that I do, right? Why? Because that motivates me, right? So do that. Comment after the class. I want to see your comments that why you were sitting in the live session. There must be some motivation, right? So what is that motivation? What was the teaching, right? So that I want to know in the comment section. Now, guys, we have not the last topic, the second last topic, because this is the last major topic of today's class. Other topics are small, that is Carbonyl, that will hardly take us 2 to 3 minutes. Okay, so this is the one last major topic of today's class, that is CFT. So CFT basically it says that okay, you have electrostatic interactions, right? It does not. It says that it has ionic interactions. So it takes it as point charges, right? So that you don't have to remember. What you have to remember is that what happens in the octahedral crystal field theory. Firstly, what was there? All the ligands, all the orbitals of this d orbital, right? All these subshell, all the orbitals were having the same energy. They were best friends, right? After that, what will happen? Ligand will come into their life. So their energy will increase. All of them will be like very happy, very excited. Oh my God, JEE means is there. I'm very happy. But some of them will pass, some of them will fail, right? All of you are sitting in the same class. All of you are studying, but some of you may fail, some of you may pass, right? You can say there are 5 friends, right? Some ligand, some girl will come into their class, and some will be having high energy, some energy like okay, low energy, right? Not interested, right? So that is how ligand will behave with the metals, right? This is degenerate, means all have the same energy. This is the splitting of the degenerate orbitals, right? Now, the first question that they can ask is why in octahedral you have 2 above and 3 below? Reason lies in the shape of the d orbitals. We know that in dx square minus y square and dz square, it is along the axis, right? And do you know that in octahedral species also, if you see this, in octahedral, this is along the axis. Can you see? If this is the axis, this is along the axis. 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 Right? So ligands are also along the axis. That is the reason the orbitals which has lobes or which has electron densities along the axis, their energy will get high, right? And this is split into dx square minus y square and dz square. Okay. Now to name these things, this is called EG, G for gerade, because octahedral has symmetry, right? That is why G for gerade, that is symmetry. So this is called EG, this is called T2G, this is the barycenter, the center point. From this point to this point, you have 3 by 5 delta naught. And from this point to this point, this is 2 by 5 delta naught. This question is also asked. Okay. This is plus of 3 by 5. This is minus of 2 by 5. Let's take an example how the question is asked here. Let's take an example. You have 5 electrons and you have strong field ligand. Strong field means the splitting is very high. Weak field means the splitting is less. When the splitting is high, it will be difficult for you. For example, you have to go to a floor number 48. There is no lift. You will say, I don't want to go. If I say you just have to go to floor number second floor, so you'll say, okay, I can go by stairs. That is possible, right? So less is the splitting, the electrons can jump in the next energy level. But if the splitting is very high, the electrons will not jump. They will cause pairing like this only. 1, 2, 3, 4, 5, 6. Or you can say they will cause pairing like this. Not this is not the right way. This is the right way. 1, 2, 3. First, all degenerate orbitals will be filled. After that, you will have 1, 2, 3. So, how electrons you will fill? Now, I am assuming that all the let's assume that you have strong field ligand. That means the splitting is very high. So, how you will fill? 1 electron like this, 2 electron like this, 3 electrons like this, 4 electron like this, 5th and 6th, then 7th, then 8th, then 9th, then 10th. That is how you're going to fill the electrons for strong field ligand. If the splitting is less, okay, weak field ligand. So 1 electron in the same way, second, then third. 4th electron here. Why? Because you can easily go to the second floor because the gap is very less. 1, 2, 3, 4, 5, 6th, 7th, 8th, 9th and 10th. Understood? That is how you're going to fill the electrons. Now, how the numerical based question is asked here. Let's say you have 4 electrons and they are saying that it is a weak field ligand, okay? So, 1, 2, 3 and 4. Now, they are saying what is the value of delta O? What is the CFSC value? So, you will say 3 electrons here, 3 multiplied by minus 2 by 5 plus of 1 electron here multiplied by 3 by 5. That is how you are going to know the answer. Okay, that is how you will have the answer. Got it? Understood? Everybody understood this or not? Let's say you have 5 electrons here. 1, 2, 3, 4, 5. Then this will change to 3 only. This will change to 2 because now here you have 2 electrons. Understood? Is that clear? Yes, this is T2G3 EG2. Right? You can also write the electronic configuration in the same way. From one diagram only, I made you understand everything. Now, I am writing something very useful for you here. If they say strong, weak field, that means the CFSC gap is less. If the gap is less, there will be pairing or no pairing? Obviously, there will be no pairing because the electron can easily jump to the next level. So, there will be no pairing. No pairing. If there is no pairing, this is 1, 2, 3, this is 4, this is 5, it will give rise to high spin complexes. So, here you can also write high spin. High spin. Okay. In the opposite manner, this is CFSC is going to be very large. Gap is going to be large. Okay. Then that means there will be pairing. There will be pairing. That means it is going to be a low spin complex. Okay. It is going to be a low spin complex. Understood? Yes, thermodynamics I am going to take next Friday. Okay. I'll share the schedule with you. Next week's schedule I'll share on my own Telegram channel, that is t.me/Diksha Kaushal Chemistry. Okay, t.me/Diksha Kaushal Chemistry, or you can also type Diksha Kaushal Chemistry official. Right, I'll share on my Telegram channel. Right. Next is CFSC in octahedral, because we have strong field, weak field. So this is the spectrochemical series from where the questions are directly asked. Right, directly they will ask you this. First you have halogen SCNCl, S2 negative, and here water is the in between. Then you have NCS, EDTA, NH3, ethylene diamine, CN and CO. This is the maximum having the high strength. Right, then you have CN, then you have EN. This is the spectrochemical series, the order of crystal field splitting. And next we have is tetrahedral complexes. So in tetrahedral complexes, what you have, because in tetrahedral, this is how tetrahedral looks like. Okay, this is how a tetrahedral species look like. A tetrahedral compound, because it does not have any symmetry, that is why we don't add G here. We don't add gerate here. Right, first point. Second is, Ma'am, in octahedral, we had dx square minus y square and dz square. That is having high energy. Here we have opposite. Reason is because can you see in tetrahedral, this is the structure of octahedral, this is tetrahedral. In octahedral, you can see on axis you have the atoms. That means in octahedral, those orbitals will have high energy which have along the axis, which have the electron density along the axis. But in tetrahedral, if you see this, there is no along the axis. This is not along the axis, right? So that is why those orbitals will be high in energy, which are between the axis. So that is dxy, dz, and dzx, right? So that is going to be the answer here. Now, next is this is the barycenter, and here energies will switch. This is the barycenter. Here you will have minus 3 by 5, and this is plus 2 by 5 delta T. Now, always remember that delta T is going to be 4 by 9 of delta O. Very, very important. That is, tetrahedral is almost half of octahedral. That means this is octa, then tetra will be this. That means tetrahedral species will always have, even with strong P ligand, they will cause less CFSC. If CFSC is less, that means the electrons will cause no pairing. That means they are always going to have high spin complexes. Okay, always tetrahedral will have high spin complexes. This is also a very, very important theoretical point that they can ask you in the exam, that tetrahedral species, they are having high spin complexes, right? Okay, this we have already done, right? Relation between delta D, this also we have done. Now the limitations here are, this theory take assumption that ligands are point charges that I told you. That's why we don't know, because ligands are not point charges in reality, right? Again, this theory should exert the greatest splitting effect, but anionic ligands actually are found at the lower end. Now they are saying, if you are saying that electrostatic interactions are there, that means according to the charges, the interaction should be stronger. But if you see the crystal field splitting, the spectrochemical series, the negative ligands are at the lower end of the spectrochemical series, which also is a limitation. They should not be at the lower end, right? Because they are negative, more charge, more electrostatic interaction. This is also not right. It does not take into account the covalent character. They are saying this is electrostatic. So this also we are not able to understand. How can you ignore in coordination compound? How can you ignore the covalent character, right? So these are the three limitations. Now let us see the questions, right? Based on this, I think we are left with just few topics here, very small topics. First question on your screen, everybody. Yes. Let's listen now. Very good, Praveen. Yes. Two complexes, these are violet. Now, let me tell you one thing. JEE means is focusing on the colors of coordination compound, right? So you cannot ignore that thing. That's why I have taken up those questions where there is a mention of color, right? Two complexes are violet and yellow colored. The incorrect statement regarding them is, the incorrect statement, guys, both are paramagnetic with 3 unpaired electron. Let us see if they are paramagnetic or not. I'll tell you why. Because, okay, let's see the first only, because with the first, so you will be able to answer it. Now, they are saying two complexes are violet. This is violet color, right? This is yellow color. This is yellow color. So, the color that they will show is complementary to what they will absorb, right? So, delta O value of A and B are calculated from energies of violet and yellow light respectively. No. Delta O is calculated with the absorption, which is the value which is the light that they are absorbing. They will give you the opposite complementary color, right? Complementary color means, let's say you have VIB, GYOR. This is GYOR, VIB. So that means red will give you blue color, right? Violet will be given by green color. So that means that is not the complementary value, right? So here we can say this is the incorrect statement. Both are paramagnetic. If you see this here, both are paramagnetic or not. This definitely we know A is the correct answer, but still we have to know. This is Cr 3 positive and this is Cr again 3 positive. So both will have the same thing only, right? So chromium is nothing, it is 4s2, 4s1, 3d5. After losing 3 electrons, it will be 3d3. So that is going to have 3 unpaired electron, because water and NH3, that is going to have 3 unpaired electron. Both are paramagnetic with the 3 unpaired electron. Chromium, if you with chromium, ammonia will not cause any pairing, so that is also right. Both absorb energy corresponding to their complementary color, that is also right. Delta value of A is less than B. A, if you see the delta O value of A, water, and this is obviously less, because in spectrochemical series, water is less as compared to ammonia. So that is also right. This is very, very important point, because when you have with chromium, you have amine that will not cause any pairing. That is the exception. That is why I'm saying this is important. This is the exception. That is why this becomes important, right? Okay, so answer is going to be A is the correct option and the incorrect statement. Okay, A is the correct option. This is a very good question. Okay, next is identify the trend given below. Okay, identify the trend given below. So delta O values are given to you. Remember that delta O value, if you have more oxidation number, delta O value will be greater. So from the oxidation number, we can see that here titanium is in +3 oxidation state, here it is in +2 oxidation state. So more is the oxidation number, more is the CFSC value. So this is also correct, this is incorrect, this is incorrect, this is also correct. Okay, you can write here that CFSC is dependent on oxidation number. More the oxidation number, more is the value of CFSC. From here, what you can see, the difference is, this is water, this is water. The difference is in the central metal. That is, this is chromium, this is molybdenum. Chromium, molybdenum, chromium, molybdenum, chromium, molybdenum. Now, always remember that as we go down the group, right, CFSC will increase. As we go down the group, CFSC will increase, right? So here what you can say, that molybdenum will have more as compared to chromium. So answer is going to be C. Okay, as we go down the group, CFSC is going to increase. So molybdenum will going to have more delta value as compared to chromium. This is also a very, very interesting question based on the factors of CFSC. One is more is the oxidation number. 3 factors, I'll just write it here. One is oxidation number. Second, you write here. Down the group, CFSC increases. Third is maximum is for square planar. Then there is octahedral. Minimum is for tetrahedral. Okay, minimum is for tetrahedral. These kind of questions, based on these 3 points, they ask you. Okay, based on these 3 points, factors, they ask you. Now, in this JEE Mains 2024 attempt 1, 2025 attempt 1, what we have observed is they are asking question on the colors. That's why I have given you this color chart here, because this is from your NCERT, right? That is why this automatically colors, they are asking only those colors which are mentioned in your NCERT. Now, this is not a short topic, right? But the trend is changing. That is why I have given you this particular chart, that you should once go through the colors here, okay? You should once go through the colors, which is the color of that coordination entity, that you should know, okay? That you should know. Just go through this table once. Next is, if you talk about the wavelength here, right? We know that E is equals to Hc. E is equals to Hc by lambda. That means E is inversely proportional to lambda. So more is the value of CFSC, less will be the wavelength. Okay. So if they don't ask you the value of CFSC, they can ask you the value of wavelength. That is inversely proportional. That you should know. right? Okay, stronger ligand, greater splitting, more CFSE means less wavelength. So that is, as we know, longer wavelength, okay, is equals to low energy. Now, if you have strong ligand, greater CFSE, energy is high, that means wavelength is less. So here, wavelength, lambda is shorter. Lambda is shorter, right? But if you have weak field ligand, in that case, splitting is less, energy is less, so lambda will be longer. Okay? That's it. That is over here that we know. Next is, let us see which of the following compound is not colored. Is not colored yellow. That is again from colors, right? That I have told you. Which are the following compound? K3CONO2 6, yellow color. NH34, this is also yellow color, right? BaCrO4, this is also yellow color. So answer is A is not yellow colored compound. This has been asked. This is a memory based question, right? Memory based question, you should do only the previous year questions and the colors that are mentioned in your NCERT. Don't go beyond NCERT. Okay. Last topic of today, and the very small topic, that is carbonyl. If you have carbonyl as the ligand, then what are the, they will ask you question directly from these structures. Okay, then I'm going to write here the structures. This is nickel. Okay, this is CO, this is CO, this is CO, this is CO. Okay, these four. Then you have iron, again 1 2 3 4, CO, 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 CO. CO means carbonyl here. Chromium will have CO, 6 ligands in the octahedral geometry, right? 6 ligands in the octahedral geometry, right? This is trigonal bipyramidal geometry. This is tetrahedral geometry. Okay, this is tetrahedral. This is trigonal bipyramidal. This is octahedral geometry, right? Trigonal bipyramidal geometry. Anybody wants to know? Anyone wants to know trigonal bipyramidal? I won't be able to make it here. Chalo, trigonal bipyramidal means in one plane you have one atom like a trigonal plane at 120-degree angles. One is above, one is below. That is trigonal bipyramidal. Now, these two are most important structures, right, that they usually ask question on. Mn2 and carbonyl 10. So, manganese is going to have two manganese here, and both, that means two octahedrons are linked to each other. Okay, two octahedrons are linked to each other. This is a very, very, very important structure where you have cobalt. This is cobalt that is also linked with each other. Here you have one bridging ligand, right? There is one bridging ligand, three terminal here. Okay, three terminal here. So from here they ask you question, how many bridging ligands you have? So you have two bridging ligands and 6 terminal carbonyl ligands you will have. Okay, that you can answer. Okay, last is synergic bonding, a very small question based on metal carbonyl. So synergic bonding means back bonding. We know that ligand are supposed to give electron to metal. What if metal also starts giving electron to the ligand? That is back bonding. Okay, so ligand is giving electron to the metal. That is, we know ligand is giving electrons to the metal in the simple vacant orbitals of the metal. But when metal is giving the ligand, that is, when metal is giving electrons to the ligand, it is doing that in the pi star, anti-bonding pi orbital. This is a very important question. When ligand is giving metal the electrons, it is a simple the vacant orbitals of the metal, right? But when metal is giving the electrons to the ligand, When the metal is giving electrons to the ligand, that will be anti-bonding pi star orbital. This question is frequently asked. Okay. Now let us do the last question of today. Everybody, let us do the last question, that is CO2, CO2, CO8 that I have just told you. One CO-CO bond it will have, 6 terminal and 2 bridging CO. The answer is A is the correct answer. Okay, this we have seen here also. This we have seen here. 1 CO bond, 2 bridging and 6 terminal. Okay, and these are the terminal. 6 terminal carbonyl ligands it will have. Okay, so from here the questions that they are asking you. Right? Okay, understood? So that was about coordination chemistry. We have covered it in complete 2 hours, right? So I have taught you all the important concepts, right? As easily as possible. We have also done questions based on that. But if you want to do that in more detail with more questions, right? You want to prepare yourself for attempt 2, then we have this batch for you, that is crash course batch for attempt 2. Here we are providing you everything that you need. First is targeted revision, right? On daily basis, you will have your lectures, right? Focus on high scoring topics and weak areas, usually by the students. Speed and accuracy boost will be there with the help of DPPs, with the help of quizzes in the class only, right? Then smart practice, how to use tricks in between the class. We'll tell you about it, how to use this trick, that trick for your to save your time, especially for mathematics and physics, right? Okay, because in math and physics students lose their marks. So especially for mathematics and physics, you need this smart practice, right? Then mock test and analysis will be there. So mock test every Sunday that is happening, right? Till your exam. So with that mock test, you will also be able to analyze what is there and what is not, what are the weak areas, everything will be there, right? Now, the batch has already started from 12th of March. It has already started, right? It will end on 20th of April, right? Daily classes, if you talk about, daily sessions are there. From 3 p.m. to 4:30, there is one class, then 4 to 6:15, then 6:45 to 8:15, then 8:30 to 10. That means from 3 p.m. to 10 p.m., you are completely occupied in the batch itself with small breaks in between, right? Okay, so that you can revise the previous class. Now, before 3 p.m., what you have to do is we'll give you DPPs, we will give you practice questions for that particular chapter. You have to do your homework before 3 p.m. Right? Okay. Now, if you talk about in class, you will have live classes, you will have in class doubt solving, quizzes, leaderboards, practice question discussion, and previous year question discussions as well as in the class itself. Right? I have taken only a few previous year questions, but we will take full all the previous year questions, most important in the batch. Right? Handwritten notes after the class will be provided on that same class. It will be uploaded. Assignments, replay more recordings will be there. Pedagogy app and VBuddy for small bits, right? Exclusive Telegram channel for those students who have joined the batch. Now there are three main things for the batch, three kinds, I would say, three additions that you have in your batch. One is your simple crash batch, right? In this you have JEE means 2, attempt 2, all the classes, everything, and VIT triple E classes after we are done with JEE means attempt 2. Then in crash combo, you also have KCT and Comet K test series along with this JEE Mains 2 and VIT triple batch, right? If you take crash pro, addition to JEE, VIT triple E batch, KCT and Comet K test, you will also have printed JEE previous year question books delivered at your home, right? Now, if you talk about the price here, crash is at 999. By adding 1000, you will get KCT Comet K test series as well. By adding one more 1000, you will also get printed previous year question booklet for physics, chemistry, and mathematics delivered at your home at 2999. Okay, so I would suggest you go for this particular thing. Reason being, you will also have KCT Comet K, right, test series in your hands, And you will also have a previous year questions booklet, right, for all the 3 subjects, which individually will take you, like, which cost you, right? So everything is given. The link is in the description for the batch. And if you want to purchase the previous year question booklet for JEE Mains, that is available at 999 for you, right? Okay. So I would advise you to go for Crash Pro, which will have everything that you need for next 2-3 months. Okay. Is that clear to everybody? Okay. Now tomorrow I'll be taking up one more lecture where we will be doing electrochemistry, right? Okay, students. So tomorrow class, we will be doing electrochemistry. Electrochemistry. Beta, why I am picking these chapters? So firstly, I am picking the high priority chapters. First, I have done chemical bonding and coordination compounds. Now, I will be picking electrochemistry. In this week, we will be doing electrochemistry, equilibrium, and thermodynamics. These 3 chapters, very, very important chapters of physical chemistry, we will do in this week, right? Okay, all the important concepts, important formulas, along with the kind of questions that they ask you here. Okay, is that clear? Okay, thank you so much, yes. Thank you so much, everyone, for your wishes. Thanks a lot. That means a lot to me. Now, I'll be waiting for your comments in the comment section. I'll be waiting for the chapters. Okay, also list down in the comment section, list down the chapters that you find difficult. Okay, in the comments, list down the chapters that you want me to take up. Okay, 3 chapters I have already told you. This lecture will be at 3 p.m. tomorrow. This is other 2 are at 11 a.m. only. This is at 3 p.m. tomorrow. Okay? Yes. Okay then. Bye bye. Take care. See you all in tomorrow's class at 3 p.m. for electrochemistry. Bye bye. Take care. See you all, and I'm waiting for your comments in the comment section. Bye bye. Ma'am, PDF. PDF, beta, that will be provided in the description box tomorrow, right? Because today the team is not available. It's your Diksha ma'am who is teaching, right? But others, today is Sunday, so everybody is like on leave. Not on leave, it's a holiday. So it will be uploaded by tomorrow in the description box as well as in the comment section. Okay? Okay then, bye bye.